Hello, I'd like to introduce myself. My name is Jason Correa, and I've been working in the industry for over 15 years and now teaching part-time here at Chabot College, electrical principles in safety and introduction to electronics within the Electronics and Systems and Technologies lab. Did you know as little as 100 millivolts can cause ventricular fibrillation, or otherwise known as making your heart beat very fast, and essentially could cause a heart attack? Throughout this quick discussion, we'll cover such things as what is electricity, how can it harm you, and how can we be safe in our homes for the non-electricians. So let us start our conversation out with some basic information and a little bit of the theoretical aspects of electricity. Why is it so important that we learn about electricity? Well, electricity can cause all types of damage to vital organs and human tissue very easily. One of the textbooks that I often read out of is Milovy's 2000 version of Electrical Principles. And he states there are two types of electricity that we really in the world today, one being alternating current and the other being DC current, such as batteries. Alternating current would be used within your home or any other industry application, where the DC current is used in our day-to-day appliances such as cell phones, cars, remote control airplanes. Milovy's 2015 textbook points out that electricity is three things: voltage, resistance, and current. Now, voltage is the potential energy between 2 points, and resistance is the opposition to the flow of electrons throughout a conductor. The electric circuit requires three things to be an operational circuit: a source of power, we could think of as a battery or a plug; a load, we could think of as a light bulb; and a conducting path, which would be the wires that provide the voltage and amperage to pass through your load. Put them all together and we have an electrical circuit. Current flows only when the circuit is closed. So now if we put them all together, we have an electrical circuit where current only flows when the circuit is closed or completed. An electrical shock can be caused when you insert your body into the conducting path of the circuit. The resulting flow of the current, otherwise known as amperage, is the shock. Have you ever heard the term, "it is not the voltage that'll kill you"? It is actually true. What it is the amperage that will cause a shock throughout your body. The severity of the shock is a function of the current that flows through your body. That slight tingling sensation you get when you put a 9-volt battery to your tongue is electricity flowing through the negative to the positive of your tongue. But wait, if you don't have voltage, it is impossible for the current to flow through your body. If you increase the voltage across the load, the current will also increase. Who has ever heard the term, "it is not the voltage that'll kill you"? Well, this is actually true. It is the severity of the shock in most cases that will cause the current to flow through your body and cause a severe shock. But wait, if you don't have any voltage, it is impossible for current to flow. If you increase the voltage across a load, hopefully not your body, the current will also increase. What are the effects of electricity on the human body, you might ask? Well, Jens Tech and Streichers, both doctors who have written Joshua Gentegs, an assistant professor and researcher at the Department of Energy of Omaha, and Christopher Sinches, MD, assistant professional of energy emergency medicine at Oklahoma University and community medicine, have written in the Emergency Medical Practices Yearly newspaper, November 2018, that electricity can have devastating effects on human tissue. It can stop your heart, it can burn your tissue very easily, and injuries sustained from an electrical shock can affect every organ in your body. So that could be But wait, how bad is bad? The amount of current determined by the severity of a shock can be very little. If we see here, Malovy's principles of electricity has given us a table we could look at. What we want to concern ourselves with is the bottom two rows, a possible heart attack or fibrillation. Both men and women can receive this with as little as 100 milliamps or 500 amps direct current. That is not a ton of electricity to actually cause that. We will learn a little bit about that later. The real danger is when the path back to ground passes through your heart. This is when you causes ventricular fibrillation and can burn even your heart tissue. Many times it's not just the shock of electrocution that hurts you, but it also can be a resulting fall from the shock of the shock. Now we learned a little bit about how electricity can affect us. Now that we have learned a little bit about how and what electricity is and how it can affect us, let us discuss how we can use it more wisely and safely. Electricity powers our daily lives, and we must understand enough about it to identify where hazards might arise. Pay attention to things like electrical cords, light fixtures. Look for damage. Pay attention to cords. Pay attention to things like electrical cords, light fixtures. Look for damaged electrical cords that may have cuts or frays in them. Keep an eye out for discoloration on the walls or around light fixtures and plugs. This might be a sign of overheating due to excessive amperage draw. Furthermore, keep an eye out for possible water leaks from windows or roofs that could cause things like electrical shorts, resulting in electrical shock or even home fires. Do not overload your circuits. Here I have a little chart of some labels, some pictures. Do not overload your circuits. Check how much power your devices can use by checking the labels on the back of your appliances. Here I have some labels, some pictures of some labels I had taken to better describe what to look for. On this label here on the top left, we see a coffee brewer. Now this is quite a big coffee machine from my local church, and it has a drawing of 19 to 25 amps. Here is a very old monitor here on the top right, and it is drawing 10 amps of electricity. And here, the bottom right, we have a little space heater that you might use on your desk. If we notice the label, it is drawing about 12.5 amps. Now, your regular residential circuits are generally about 15 to 20 amps. If you ever seen a circuit breaker here like this on the top right within your home, we'll notice these little numbers on here that state how much current can actually flow through these circuits. So knowing that, we want to be vigilant to make sure that we do not overload power strips or extension cords. Here on the right, we have an illustration of an overloaded power strip. This can be dangerous, especially when plugging in heavier loaded appliances such as heaters and coffee machines and large TVs, because it can cause a home fire or even melt the cords on the plugs to where when you go to unplug them, it can cause an electrical shock. Be careful when using appliances such as hair dryers or curling irons in your bathroom. This could cause a short. The presence of water can cause an easier short to ground and make a bigger potential for you to be electrocuted. So be vigilant to not blow dry your hair in puddles or in the bathtub. So before you use something electrical, look, think, and observe your surroundings. In conclusion, we've learned a great deal about electricity in a short amount of time. We have learned about what a volt, an amp, and what current is. We also have learned just how little of current can cause great harm to our human tissue. We've also learned some potential risks where electricity can cause issues in your house and to your family's health. Armed with this new knowledge, please go forth and spread the word and be safe. So the next time you use an electrical appliance, look, think, observe your surroundings.